Hello everyone. So I hope you are doing great. Today we are going to learn about LDR sensor. LDR stands for Light Dependent Resistor. L for light, D for dependent, R for resistor. It's a variable resistor whose resistance is going to be changed according to the lights falling on its surface. Yeah, and we created a module, a sensor module using that LDR, and that is known as that LDR sensor. That's great. So LDR is also known as the photoresistor. Yeah, it's a sensor whose resistance varies with the amount of light falling on it. The basic principle of an LDR is based on photon photoconductivity. Yeah. So now we are going to go dive. What is the photoconductivity? How we can use that in LDR, and how LDR is working. What are the characters of the LDR we are having? What are the uses of LDR we are having? And we are going to integrate with the microcontroller as well. These are the activities we are going to perform over there. So let's start with the working principle. Yeah. So what is the working principle of LDR? Yeah. What is the physics behind this? So the working principle of LDR is photoconductivity. Photoconductivity. Yeah. So the material is used in LDR is semiconductor material like cadmium sulfide, CDS. Cadmium sulfide is a material, semiconductor material, by which we can create LDR. Yeah. So CDS stand for cadmium sulfide. These material have properties that changes when exposed to light. Yeah. And we already discussed the working principle of LDR is photoconductivity, and LDR is generally made up of semiconductor material like cadmium sulfide. And so, what is the photoconductive effect then? We discussed photoconductivity is the working principle. So, what is that actually? So, the photoconductive effect. So, when light photons is the light particle. So, these are the symbol of photons. When photons strike with the semiconductor material, they impart energy to electrons in the materials. Yeah, exciting them from the valence band to conduction band. This process increases the number of free charges carrier, which reduces the material resistance. So what happens in semiconductor material? We are having bands. So we have two bands. This is a valence band and it is the conduction band. what happens when light is going to be fall on the valence band over there, then what we are going to have, we having the lots of electrons over there. Yeah, so valence band is full with the electron and conduction band is generally empty. So when light is going to be fall on that material, that electron is going to get the energy, and due to that energy they are going to jump into the conduction band. When lights fall on the valence band, these electron is going to be jump into the conduction band. That's how the resistance is going to be decrease of these material and conductivity is going to be increase. The more electrons is going to jump from valence band to conduction band, the more electricity is going to be increase, and the voltage is going to be increase, and in that resistance is going to be decrease over there. Yeah, so if the electron of valence band is going to be jump into the conduction band, then what is going to be happen, that resistance of that material is going to be decrease, and the flow of electron is going to be increase. So this is the photoconductive effect. Yeah, if light is going to be increase, then resistance is going to be decrease of that material, and if light falling on that surface of the material is going to be uh, increase, the conductivity of these material is going to be increase and resistance is going to be decrease. Yeah, so this is the photoconductive effect. And what is the important part over there, that balance band and conduction band theory. Yeah, so this theory is related to semiconductor material, and we have energy gap over there in conduction and balance band, and it varies from uh, it's the energy gap which we have in between the conduction band and valence band, we having in the energy gap is known as, is calculated in the electron volt. Yeah, so generally it varies from 1 electron volt to 3 electron volt. 3 electron volt is much higher. If it is greater than 3 electron volt, then it's an insulator, and if they are overlap with each other, then it's a conductor. In conductor, valence band and conduction band are overlap with each other. In semiconductor, we have the energy gap between 1 to 3 electron volt, and the material which having the energy gap more than 3 electron volt are the insulators. Yeah, so this is the photoconductive effect we are having. If light is going to be fall on the material of that semiconductor material, like cadmium sulfide, so the electron of the electron present in the valence band of the cadmium sulfide is going to be jump from valence band to conduction band when light is going to fall. Then electricity or the conductivity of that material is going to increase, and the resistance of that material is going to be decrease. Yeah, if light is not going to fall on that material, means the valence band electron is still in the valence band electron, and they are not going to jump into the conduction band, and that means the resistance is going to be high, and conductivity is going to be low. So this is the explanation of the photoconductivity. So after the material discussion, cadmium sulfide and photoconductivity thing, now we are going to be just discuss resistance change. So what is the resistance in darkness? What is the resistance in light? As we have discussed, yeah. In darkness, the resistance in LDR. So we have two conditions, in dark and in light. So in the absence of light, in dark, LDR has high resistance. In dark, generally, LDR is having high resistance because there are fewer electrons available into the conduction band. Yeah, so that's why the conductivity is low and resistance is high. In light, when exposed to light, the resistance of LDR decreases significantly due to the increased number of free electron generated by the light or photons. Photons are the light particle. Yeah. So in light, the resistance is going to be low and conductivity is going to be high. Okay. Now, after that resistance discussion, we can go to the electrical characteristics of the LDR. So what is the electrical characteristics? Electrical electrical characteristics. So we have the variable resistance in LDR. Resistance is going to be changed according to light, isn't it? So one is the property or one is the characteristics of the electrical LDR is variable resistance. One of the most important electrical characteristics of the LDR is variable resistance. So these resistance are in mega ohms. When there is a dark, these are in mega ohms. And when there is a bright or there is a light, these resistance having some ohms over there, some 100 ohms you can say over there only. So this is the electrical characteristics of the LDR, variable resistance. So in dark, they have the mega ohm, and in light, they're going to have some 100 ohms, yeah, 100 and 200 ohm, these type of resistance they are having, yeah. So you can say few 100 ohm in light. Second electrical characteristics of that LDR is non-linear response. So what is that non-linear response? The change in resistance is not linear with light intensity. Like if you are going to increase the light, yeah, then conductivity is going to be increased. If we increase some more light, then some more conductivity is going to increase. If we increase some more light, then some more conductivity is going to increase. Like linear thing. Like if we increase the light by 2, then conductivity is going to increase by 4, and if we increase light by 4, then conductivity is going to increase by 8. This is the linear, yeah. If we increase light intensity by 2, conductivity 4, light intensity 4, and that conductivity is 8, and if light intensity is 8 and then conductivity is 16, it's not going to like that. It's not going to be like that. Means if you draw the linear graph, then how it is going to be present? It is a linear graph. If light intensity and conductivity is going to be increased with the same proportion, Oh, sorry, conductivity. Light and conductivity. If light and conductivity increase with the same proportion, that means it's a linear, yeah. But it is not like that, guys. What is going to be happen? The change in resistance is not linear with the light intensity, but rather follows a logarithmic relationship. This means a small change in light intensity can cause large change in resistance or conductivity. Yeah. If we are going to be increase the light, yeah, then resistance is going to be decrease. Yeah, that's how. And if we are going to increase the light, then resistance is going to decrease very quickly. Yeah. So that thing can be happen. So the response is non-linear, guys. No, we have talked about the non-linear response. Now, what we can uh, be perform. So what can we do about it? How can we use that LDR? We can use that as a voltage divider. We can use LDR as a voltage divider. LDR commonly used in voltage divider circuit. Yeah. So what a voltage divider consists? Voltage divider consists of an LDR and a fixed resistor connected in a series. So it's a LDR, variable resistance. When light is going to fall in it, then its resistance is going to be changed. Yeah. And it's a fixed resistance and they are in the series. Yeah. So this is the and okay, and what you can do in that LDR, you can show that thing as well. Resistance, then when light is going to be fall on it, that resistance is going to be changed. That's how you can show that. It's more cool way to present LDR, yeah. So we can show LDR like this. LDR is a resistance as well, but it's a variable resistance, and when it's going to be changed, when light falls on it is going to be increase or decrease. So this is the voltage divider when LDR and fixed resistor are in the series. And and the voltage across the fixed resistor there is going to be changed if light of that LDR is going to be changed. Yeah. If it is going to be changed, the voltage across this fixed resistor is going to be changed. That's how that voltage divider circuit works over there. We have two things, LDR and a fixed resistor in a series. And if the light across the resistance of LDR is going to be changed, then voltage across this resistance is going to be changed. This is the voltage divider circuit. Yeah, we are going to create this in our upcoming activity as well. Yeah, don't worry about that. Now, the second use is analog signal. Analog signal. So the output of the voltage divider can be read as an analog signal by a microcontroller. Yeah, the varying voltage corresponded to light intensity, which can be measured and processed. We are going to create the circuit now. Yeah, so we are going to create a voltage divider, and then we are going to use that voltage divider with the microcontroller, and we can perform some task over there. We are going to measure that voltage across that junction as well, and we are going to be control an LED as well according to the code, according to that LDR sensing. Yeah, so what this circuit need, so we are going to be goes into the circuit designing part. So we are going to have an LDR, we need a LDR, and what we need a fixed resistor, we need an LED, fixed resistor we have, and that LDR we are having, we having the LED, and we need a microcontroller as well. And we have Arduino in this case. Yeah, Arduino we are going to use Arduino Uno. So these things we are going to have in that, and we need some jumper wire as well to connect all these things. And yeah, that's it we need. And you can use the breadboard as well if you are going to create this circuit in real. You need the breadboard for that as well. Okay, now we are going to create the circuit now. So now we have lots of theoretical discussion on that LDR, and now we are going to have that practical application over there as well. Hmm. So as you can see, I already have that Arduino on the Tinkercad, and what I need an LDR. So photoresistor is another name of the LDR. You can see over there. So I am going to take LDR over there, and generally you will find LDR module in the market. It's good to have the LDR module, yeah. So that LDR module is going to have 3 pins over there. Generally 4 pins: VCC, ground, AO, and DO. AO means pins for analog input, and DO means the pin of sorry, AO means analog output, and DO means digital output. So you have these type of modules in the market already. You can go through that. But what we are going to do, we don't have the module in the Tinkercad. We only have that 2 pins LDR. Now we are going to create that module over there with the help of voltage divider. Yep. So now I have a fixed resistance. I have that LDR. I have that fixed resistor. So if you have that module with you, you don't need to do these connection. You just need to connect their wire over there. In that module, we already have that circuit embedded on into that. Yeah. But now we need to create that because in that Tinkercad we don't have that LDR module. So first of all, I'm going to connect one of the side of that photoresistor or LDR with that resistance, with that fixed resistance, which having the value of 1 kilo ohm. And then I need to connect the second pin of that LDR with that 5 volt. And then this I'm going to connect with ground. And I'm going to change the wire color as well. This I'm going to go with red, and with this I'm going to go with black. So what I did over there, I have given the power supply to that LDR so it can sense the light in the physical world. Okay. So now, so we have created that voltage divider. We have connected LDR and that fixed resistor in a series. Now what we need to do, from there we can take another wire. This is the output pin of that LDR. And now I'm going to connect this wire with any of the digital input in the first case. Okay. I'm going to connect with this 11, and I'm going to select that green color from there. So this is whole complete diagram of that LDR sensor with that microcontroller. Okay. So one of the side of that LDR I have connected with 5 volt, and I need to connect this LDR with the fixed resistor to create the voltage divider. And then I've connected that resistance side with that ground so it can get that 5 volt from that microcontroller board. And I have taken that voltage divider, one of the wire, to the pin number 11 to get the output from there. Okay. So first of all, I will show you how that voltage is going to be across the junction is going to be changed. For that, I'm going to take the multimeter from there. So positive of multimeter, I'm going to connect with pin number 11 over there, from the same pin where I've connected the output of that circuit. And ground, I'm going to connect with the ground. This is going to be black, and this is going to be red. So what I want to do, I want to check how much voltage this pin is getting, how much output from that LDR this pin is getting, or does it changing if light is falling on the surface of that resistor? Does it changing the voltage over there? Yeah, check. Now we are going to perform that activity. Okay. For that, what you need to do, you need to click on the start simulation. Now that voltage is very low, 27.7 millivolt only. How much we are giving to that LDR? 5 volt. And how much we are getting? 27.7 millivolt. The resistance is really high. If you can check resistance, click on that. It's 1.02 kilo ohm. Yep. Now we are going to change the resistance from there. If you increase the light, the voltage is going to be increased, guys. If you are going to decrease the light, the voltage is going to decrease. If you increase the light, yep, there. So you can change the resistance because we are using the voltage divider over there. But if you check that resistance, that will be changed when you use that LDR freely. Yep. So now what you need to do? Now we need to code that circuit, and according to the output of that LDR, we want to do something over there. Yeah. So now I'm going to delete this multimeter because we have check. Okay. If the light is going to increase, the voltage is going to increase. If the light is going to decrease, the voltage is going to decrease in that point. Means in the pin number 11, we are getting the electricity. Okay. And what this digital pin will do? If it is getting some electricity, means if it is getting some signal from that LDR, that means it converts that level into 1. What it will do? It will, if it is getting that 27.7 millivolt, nearly 0 volt, yeah. So what it will do? It senses 0, and if we are increasing the light from there, if we increase the light from there, then it will convert that level to 1. So if resistance is low, then it converts that level to 0, and if we increase the light, then it converts that level to 1. So we have only two levels over there in our pin number 11, 0 or 1. And now we are going to code that board according to that LDR value. Okay, so I'm going to delete this multimeter as of now, and I'm going to take that LED over there. I'm going to connect positive of this LED with pin number 12, and negative of this LED with the ground. Okay, now we are going into the coding part. We need to click on the code, then blocks to that text, and then continue. Okay, so first of all, I'm going to declare LED pin, and that and LED is going to be connected in the 12, and we are going to connect that LDR on that pin number 11. Okay, and now I'm going to define this LED pin over there. LED is as output, and pin mode, I'm going to declare this LDR as the input. LDR we are going to have as the input, and that LED we are going to have as output. And what we need to do over there, I'm going to create another variable and storage. Yeah, and what I will store in that, whatever that 11 number pin or LDR pin is going to be read, whatever this 11 number pin is going to be read from LDR. What it is going to be read? It is going to be read 1 when we are getting some light, and it is going to be get 0 when there is nothing in the surrounding, means there is a dark in the surrounding, we will get 0 from there. Okay, and whatever we are getting from that, in that pin, whatever we are getting from the sensor, we are storing inside a storage variable, whether it is going to be 0, it is going to be 1. Yeah, so that's how our board is working as well, isn't it? So how we are comparing the things? Okay, we are comparing the things from the previous memory, isn't it? So if we need to take some decision, yeah, so what we are doing, we are comparing in the mind. Okay, okay, this could be happen in the past with me, I did that thing, then I get that type of result, so I'm going to do that thing. Yeah, that's how our brain is going to work as well. Yeah, let's suppose that if you don't have anything in the mind, yeah, and the any past activity in the in regarding that. Okay, like if you are touching any hot surface, yeah, if you haven't know how much hot that surface is and what is going to happen if you touch that, then what is going to happen if you touch, then you can be burned out over there as well, isn't it? So the same thing with the machine as well. Yeah, we want to feed something in the memory, then we will compare. Okay, if this is going to be comes, then you need to do that thing. So for that you need to store something in the memory. Yeah, so storage is the memory. There you are going to store the input of that sensor, and then you are going to compare. Okay, if that thing is coming in that, then I will do that thing. So if in storage, if we are getting 1, yeah, or high, it's your choice, whatever you want to use. Then what you need to do, we are going to on that LED, digital right, and the pin number is LED, pin name is LED, and I'm going to hide that. Else otherwise, if there's a not 1 in the storage, that means it's dark. If it is bright, then if it is bright, okay, then we can, what we can do, we can off the LED. Okay, if this is daytime, then the lights of our home is going to be off, and if it's night time, then LED of our home is going to be on automatically. We can create that device, isn't it? So LED is going to be on in the night, and they are going to be off in the day. Okay, now what we need to do, we'll test out this code. Oh, what? Okay, I made O capital over there. O is going to be small, sorry for that. Now it's working. Now it's a night time, LED is on. If bright means there is a day and LED is going to be off. In the night, LED is going to be on. In day, LED is going to be off. That's how our circuit is going to be work. Yeah, and what you can do, it's a digital input. And what you need to do, you try that analog by your own. So we are going to try that motion sensor with that analog pin. I have tried that LDR with the digital pin. So try that LDR with the analog pin as well. And what you need to do, there I have created only if and else. What you can do, you can create the multiple conditions over there. Yeah. So you can get else if, else if, else if, else if uh, storage is going to be in between 250 to 500. Then what you are going to do, if else if that storage is going to be in between 700 and 1023, then what is going to happen? Yeah, in analog you can create the multiple condition over there, and you can turn on and off multiple LEDs as well, isn't it? Yeah. So that's it for that class, and we will meet again with the new sensor and the new code. Yeah, till then, bye bye.